Okay, so good morning, everyone. I am Jessica Ko. Hope everybody has a chance to grab some breakfast and are all excited about what I'm going to talk about in the next 45 minutes. I'm going to keep it short because I know time is on the essence here. Let me introduce myself again. I'm Jessica Ko. I'm the product manager in the product management team from the campus IP. Today I have Michelle, who is the engineering lead for campus IP, and Jeffrey, the marketing lead for campus IP. And the three of us are here to talk about HyperEdge. You know, when I was reading all your blogs this morning and the past 1 week, I noticed there are differences in terms of technology knowledge. A lot of CCIE here, so it gets me a little bit nervous here because I'm only a CCNA. But there are also people who knows everything about HyperEdge before I talk today, but there are also people who are expertise in SDN, BYOD, and more on data center side of things. So I would like to spend the first 15 minutes just to level set, give you guys an introduction of what HyperEdge is and what it does. And then we'll go in and talk about what we're going to do. And we'll be launching, not really just launching actually, actually coming up with that feature in spring CY13. So that's pretty soon. And we're going to end off, Jeffrey's going to talk about and show you an actual demo that's sitting in our lab right now. So the feature is there, the technology is not a hype, it's real, it's sitting in our lab. We're going through just a vigorous cycle of testing right now in the labs to make sure that everything is in place. Whatever we've talked about today will be delivered in spring CY13. So with that, let's start from the very beginning for campus IP. Just kind of level set. If I'm talking too fluffy, let me know and I'll jump straight into the meat. There's three major trends that we notice in campus IP. One, video, right? Video is very predominant right now. I have my iPhone sitting there. I have my iPad in my cube, and traffic is actually exploding astronomically thanks to companies like Apple and Google. So traffic is exploding. How do we confine them? How do we put security on them, QoS on them? Those are some of the things that are happening in the campus IP world. The second trend that we notice is wireless. Wireless is going huge in campus. A lot of the buildings here now have both wired and wireless. So we're talking about wired and wireless integration right now in campus IP world. And last but not least, I think those people who are familiar with SDN will be popping their heads out. Virtualization is also coming to campus right now, and that's also a focus for us in our roadmap moving forward. So with that three trends that I've spoken briefly, there is one major trend that it's not, or rather on the opposite side of things. Unfortunately, the IT budget and IT staff is going flat or going down because of the economy. So the focus is how do we do more with less? And I want you guys to write this in your blogs after this session, is how do we do more with less? And that's the anchor point of Brocade campus switches. We have just refreshed our whole entire portfolio from the stackables all the way to the modular chassis. Entire portfolio, the past 12 months. Brand new switches on the stackables, brand new switches on the modular chassis side of things. And there's one single anchor point that we are focusing on, which is simplified manageability, ease of use. When all the switching vendors right now are focusing on adding complexity and adding features to the network, what Brocade is trying to do is focus our innovation on simplified manageability, how to make it easier for IT staff to manage, deploy, and monitor their network. So with that, let me just go into HyperEdge Technology. Now, because at the end of this session, I want you guys to be the expert of HyperEdge Technology. I know Greg is because he's been writing a lot about it, and he probably can stand here and talk to you about HyperEdge. No. So we launched Effortless Network, the term Effortless Network, in March timeframe this year. Now, it's a marketing campaign that we started off in March, but we are now delivering. One of the key anchor points is HyperEdge. And the HyperEdge technology is the underlying technology for Effortless Network. And again, the focus is simplified manageability here. Two things that HyperEdge technology will be providing: simplified management, as well as TCO and investment protection. Those are the key things that HyperEdge technology is focused on. Now let me go right into what is HyperEdge and what is mix and match. HyperEdge technology is a multi-faceted technology that Brocade will be delivering in different phases. In spring CY13, it will be our first phase in terms of delivery, and that will be mix and match stacking. We'll be focusing our presentation today on mix and match stacking. We will show you a demo on how it works, and that's what we're going to deliver in spring CY13. So what is mix and match stacking? The traditional stacking that we have seen in the market from all switching vendors basically helps to scale connectivity and performance, just like almost like a chassis, and in some cases more driven by cost constraints that people are moving to stackable switches. But there is limitations on traditional stacking. One, traditional stacking requires you to have the same platform across your whole entire stack. At least today, all the switching vendors requires you to have that. Now, second, if you have a layer 2 stack right now in your campus IP, and you decided, I need VRF, I need layer 3 routing, I need BGP, guess what? You got to take out that whole entire stack from your wiring closet and put in layer 3 switches. That's the limitation of traditional stacking. Now, what does mix and match stacking helps to solve? Basically, mix and match stacking is you can have different platforms. You can have layer 2 switches, you can have layer 3 switches, all in a physical stack. And guess what? You can proliferate your layer 3 features all the way down to the whole entire stack. In other words, your layer 2 switches right now behave like a layer 3 switch. And it has the layer 3 switches features on it. That's the beauty. It lowered down TCO because IT managers do not need to put in all layer 3 switches in their wiring closet, hoping that in year 3 they might need some layer 3 features in day 1. So that it helps to prolong their IT budget and spending right throughout the life cycle of their network. So that's one. Now the other thing is consistency. Consistency within the whole entire portfolio. If you have some layer 2 switches in your existing network right now, and all of a sudden you feel like I need a layer 3 network in my system to the edge, for example, well, you don't need to forklift all your existing switches. You just add layer 3 switches, right? And you don't add all of them. You add just 2 on an entire stack, and you can proliferate the layer 3 switches to a whole entire stack. Now that's the beauty of mix and match stacking. Right, so let's go through a deep dive. Am I talking too much? Or there's no questions? Everybody's going, yeah, that's great. This is a good technology. All right, let me go deep dive on the technology side. Yes.
Just quick questions. Go ahead.
Just a quick question. I don't see MPLS on here. Does he support that on your northbound interfaces there?
So to answer the question on MPLS.
Or LVP, RSVP, whatever.
Sure, yeah. So yes, MPLS is a technology that's in the market. A lot of the switching vendors are pushing it. Now, once we add that in our layer 3 switches, sure, we can proliferate that to our layer 2 switches. It's not a question of that. Mix and match stacking, basically, the focus is more on pushing the layer 3 functionality down onto the layer 2 switches. So to answer your question.
This product does support MPLS?
Well, at this moment, no, we are not supporting MPLS. Is it in our roadmap? Absolutely, yes. Right. So I have Vishal here to keep me honest, making sure that I speak the right way. So it's in the roadmap. I'm pushing him to deliver it, but at this point, or I can commit on spring CY13. No, we're not coming out with MPLS features. But there's many ways to actually go mitigate around it. I mean, we're coming out with VRF in spring CY13. So depending on how the network, you were talking about virtualization, VRF might be a solution. I'm just saying.
Well, to scale, VRFlight doesn't scale, right?
Right, no.
I need the dynamicness.
Yeah, and to be honest with you, we see a lot of MPLS features requirement from the SP side of things. Mm-hmm. So our SP portfolios obviously support MPLS, so the MLX platform supports that. For our team, we are more focused on campus, where typically the network might be a little bit smaller.
So,
But
there's
I
just
hear
not-
you. You're going. No.
It's a big stumbling, at least at release.
Yes.
It's still a big moment where there's no MPLS, where it's very handy to use.
Yeah, and
It's a fundamental design change if you're
Okay.
trying to work around it, at least from what I've dealt with it.
Yeah. So it's good that you say that so that you can channel all your attention to the engineering lead here. Because it's been a big push
There's a lot
from
of
the
people
from the.
watching too. You're probably saying the same thing.
on the
No.
idea that,
Yep.
because MPLS is our scale for virtualization and phase paradigm. So the idea of that's an enterprise solution, I mean, that's legacy BUs competing, SP and enterprise
Yeah.
competing, and that's, sorry, you can't have that because it's a SP technology.
No, I acknowledge that. I mean, I come from Cisco, so MPLS is very big on the Cat 6K, which is where I lead the team before. So anyway, it's good to hear that feedback again from you guys, affirmative feedback, and we have engineering here to hear that feedback directly from you. So it's in a roadmap, as I mentioned. It's not committed at this point. All right. Let me go through and focus on mix and match stacking. Let me actually go to the next slide. What are some of the key benefits of mix and match stacking? Actually, there's 5 on this slide. I'd like to focus all your attention on the first 3 first. The first one, we drive feature consistency across the entire stack. Now, if you look at this diagram over here, we have layer 2 switches at the bottom. We have layer 3 switches on the top. The beauty, as I mentioned, about mix and match stacking is you can have different platforms within a physical stack. Right? So what mix and match stacking does is all the advanced layer 3 features, VRF, GRE, BGP, IPv6, we drive consistency in features down to the layer 2 switches. So now the layer 2 switches behave like a layer 3 switches. And I'll show you in a minute a demo on multicast routing on HyperEdge stack here. So what you, as I mentioned just now, you're looking at cost savings from day one. That's the key benefit to an IT staff. A lot of them, have to worry about CapEx and OpEx. And when you talk about CapEx, a lot of them worry about the initial deployment because that's where the bulk of the budget is. But right now, you can actually spread it across a couple of years for the IT stuff. So that's key. So cost savings, that's one. Simplified manageability. Makes it easy to provision, monitor your entire stack. It helps to also simplify your configuration as well in an entire stack. So simplified manageability is the second point. Third point is pay as you grow. You right-size your network at the very beginning of day one, right? Build what you need and add what you need later. So that's the key, the third benefit that I want to run through. Now, the other 2 at the bottom is not just a software feature. And I don't want you guys to think that it's just a HyperEdge is just a software feature because there is hardware involved in it as well. Not sure how much you guys are familiar with our ICX portfolio, but the ICX has the 6610 as well as the 6450. Those 2 particular platforms within the ICX family, in terms of features and hardware, you can't find anything like that in the switching vendor out there. Why? The ICX 6610 has not 2, not 4, but 8 10 gig uplinks. Right? That's the only one, as far as I know, that where you have such a platform in the campus, targeted for the campus environment. Greg, you had a comment?
No, I'm just tuning in.
Okay. So the 6610 is the only platform in the world right now for campus where it has 8 by 10 gig uplinks. Now the ICX 6450 has 4 10 uplinks, 4 by 10 uplinks. Now, what does that translate when you put that into a mix and match stack? You can actually double the bandwidth within the stack easily because you're looking at more uplinks here, more stacking ports here. And let me let me bring back a little bit your attention on this particular stack. Now, how do you actually stack across different platforms? Now, the ICX 6610 has, as I mentioned, 8 by 10 gig, and it has 40 gig on the back plane, 4 by 40 on the back plane for stacking. So that 8 by 10 can be used for uplinks, all right, and connectivity in a mix and match stack. Now, the 10 gig on the 6610 can be connected to the ICX 6450. And depending on your configuration, you're looking at doubling the bandwidth, doubling the performance and capability of within that stack because of the number of uplink ports. You can do the math. You guys are smarter than I am, right? So that's one of the key things from a mix and match stacking perspective. Now, in addition, because of the number of uplinks, that's more and superior than any of the switching vendors out there right now. You are looking at having the ability to do almost line rate. If you think about it, a 48 port on the ICX 6450. It has 4 by 10 gig. And if all the 4 by 10 gig can be connected to the ICX 6610 as an uplink, you are looking at almost line rate on this campus box. So that's the significance of that. So that's the last 2 points on the benefit of mix and match stacking. And just to reiterate, mix and match stacking is not just a software technology, but it's leveraging our existing hardware capabilities on the platform. Yes, I have a question. Do you have a question?
Yeah.
Paul?
Can you comment on that? The third switch down, it looks like there's an extra horizontal interconnection there from the left.
Are we talking about this one?
Yes. Over on the left, it's like it looks like your layer 2 switch stack has got a closed loop, and then there's a second set of loops between the layer 2
Is there
and
a
layer.
slight error?
No, actually, the way you would stack them is you use it's actually a ring where the 6610 would be connected through the 40 gig ports, and the 6450 connected to 10 gig ports, and then the 6450 to the 6610 so it's 10 gig ports. So actually, you are creating a standard stacking ring.
Okay.
The exception is that between the two 6610, you have a much faster connection than between the 6610 and 6450.
Okay.
But it is a ring. It is a
Okay.
stacking ring.
And Paul, I would ask you to hold your thought. I have one more slide I need to show, and I can get right to your to answer your question on the topology on how we suggest that can be done.
Okay.
Let me just go quickly on this slide. Now, this slide is just more of a pictorial of what I've mentioned just now, the benefit of mix and match stacking. I talk about the 4 by 10 gig uplinks here, which is unique on the 6450 platform. Not all the campus platforms have 4 by 10 gig, just so you know. This is just a typical scenario where you will get from any other switching vendors. This is day 1 where you need a basic layer 2. For a Brocade, you'll be going for the ICX 6450. And for our competitors, a basic layer 2 stacked. And typical, they will have 2 by 10 gig, you name it, Cisco, Juniper, HP, those guys. They all have only 2 by 10 gig uplink on their campus portfolio. Now that's just day 1. So day 1, this is the topology. Now, day 2, now I'll go through that. A year later, you decided, all right, I need this to be layer 3. I need to add in all these functionalities and advanced functionality on this particular stack. For Brocade, you just need to buy 2 more of the layer 3 switches, the ICX 6610. And as I mentioned, with mix and match, you can proliferate. And the whole entire stack behaves like a layer 3.
So let's
You have
get
layer 3
technical for a bit,
Yes.
right? So I have, let's simplify it, 4 switches in a stack. My router's northbound to me. Say I'm running OSPF, right? Do I see 4 individual OSPF instances? Do I see one large OSPF instance with 4 interfaces?
You'll see only one. So what we do is we still centralize the control plane to the 6610. So they will do graceful restart and all those good things that stacking supports today. But the routing instance will be running on the active and will be syncing information to the standby. So there will be only one routing instance for that entire stack.
Okay.
if you so want, like if you want to create 5, 6 different for different areas and all those, you can. But in general, it will be only one because still the centralized.
And as the rest of my network sees it, I'll see a 4-port, say I only have 4 uplinks coming out of it,
Yeah.
but a 4-port, like a port channel, or 4 individual links, and do link load balancing across it.
Exactly. So you won't have like one instance running on each of the boxes then. It will be still running on the 6610.
Yeah, so
you could actually have multiple instances if you want, and we'll actually cover that as well.
So basically, your layer 3 instances are effectively running the supervisory function,
Yes.
and
So
then
just
you're treating
imagine-
the other switches like remote like cards.
Exactly.
Yes,
So-
that's right.
But data,
That's pretty
data
right.
plane port mappings are being replicated down, right? So you're not flooding from the control plane down, are you, to do MAC address learning?
So like when OSPF packet, which is a multicast packet, comes in like in the earlier phase of the OSPF neighborship, when it is getting formed, at that time that packet comes on one of the L2 boxes. They don't understand the OSPF packets. They will redirect that packet to the 6610, which will take that packet and do all the OSPF processing. So the packet will come on each of the member ports, but it will go to the 6610 to do the OSPF membership formation.
So even though I have equal cost load balancing distributed across 4 ports coming into my theoretical 4 stack switch,
Yes.
all my traffic, no matter which port it ingresses on, will come up to my whatever switch is running my soup, or as a super holding the routing function, and then be pushed back down through the loops down to the host.
Yes.
Yeah.
Okay. What about egress? So I have a switch, or I have a host that's on 3rd stack down, right?
Okay.
And my default gateway is housed in this stack, and I want to send it up. Do I also to egress the switching wire? Do I have to go up to my soup, down, and then out, or can a layer 3 switching event happen locally?
No, layer 3 switching will still happen on the 6610.
All the way up.
Yeah,
all the way
because
down,
that
and
is the
out?
hardware which is routing capable, meaning all your routing blocks, the longest prefix match, next hop, all those are being done on those boxes. Layer 2 switch will behave like a layer 2 switch. If it's a layer 2 multicast packet, it will handle it on the box itself. It won't send all the way to the supervisor in some sense.
It's multicast like IGMP down.
Yes, also, yeah.
So it's doing local L2 switching on those entry-level switches, but for L3 switching, it has to go to the controller. It's actually kind of like a chassis.
So it sounds like a design constraint inside of this would be understanding and managing your intra-VLAN traffic, and balancing out your uplink traffic with your available backplane traffic. You mentioned that ease of management is a key design goal. What features are you bringing forward in this platform to help manage that design constraint?
So one of the key things, as I think Jessica mentioned earlier also, that today like all these different variants of the switch, you don't have to know about their uniqueness of their CLI and everything. You can manage these different flavors of boxes. Potentially there will be a lot more as we release new products. You can manage all those boxes from just one single active unit, which will be the 6610 unit for its current stack.
So you have consistency in terms of the features and the configs and everything, right? For the whole entire stack, even though there are different platforms.
If you look at for a small deployment, this looks like you are collapsing the aggregation and access in one stack pretty much. Your top 2 boxes are layer 2 boxes, which are your like aggregation, a typical 3-tier. These are your aggregation boxes. And all your L2 boxes are also part of the same stack. Now you are managing your aggregation and access layer through single IP management, single point of management, I'll say. So again, once we scale this further out, you can deploy this in much bigger campus environments as well.
Also, the design choice of actually doing all the layer 3 and essentially the controller is that we could actually build very, very cheap switches, simple layer 2 switches, to just add ports when needed. Right? So really, there's a dramatic cost reduction when you're adding ports in such a configuration.
And if you're building a colo and you're doing top of rack, Brocade has a financing program where you actually pay for port use to go with it. So instead of actually buying the entire switch, you buy per port.
So it's a tiered lease,
Yeah.
effectively.
We have the BNS, not going to business discussions here, but BNS basically is you pay as you go. It's called like the installment kind of program as well, so within the Brocade. And this is unique to us.
So like a port activation license, true it up, or?
It's more like if you think of it, it's like a credit line. You kind of you don't have to pay everything in day one, but you pay it in
I
installments.
understand that. So
Yeah.
I got a
But you
24
could
port
actually-
switch my first day at work. I mean, we've seen this on silkworms years ago, right? Or I guess actually they have them on silkworms. But a port activation license for 8-port groups. You know, it's the same thing. You go ahead. I'd install 24-port switch and then request an 8-port license.
So in the case of the 6610, when you buy the switch, actually the 10 gig uplinks are actually 1 gig, and then you buy licenses to enable 10 gig by group of 4.
Yeah.
So that's less expensive to buy, and then you buy the license as you need them.
Yeah.
Okay, so it's not a leasing. So it's not a leasing program. It's just a licensing program.
Well, so there's another, so that's a different
two,
program.
There's two
Right.
different programs, right? So
We also,
We shouldn't get off track.
Yeah,
I'm just
sorry.
saying there's some
Yeah,
interesting
yeah.
financial options if you're
Yes,
building out a
yes.
large data center.
Mhm.
You don't have to buy
Just so you
everything.
guys know, in the bags that I have for you guys with the sticks, there is actually some more information on the BNS in that, so.
Mhm. Right, so I'll go through this fairly quickly because I want to make sure you guys see the real thing, not just fluffy slide decks here. So this is just an example of doing a mix and match. And I chose video multicast because right now there's a lot of trend where you're looking at layer 3 multicast requirements in the access, right? Primarily driven by some of the applications that are sitting on the video devices. So anyway, so this is just an example. The 6610 has, as I mentioned, a 4x40 gig stacking at the back. And so with that, you get 320 gig stacking capability when you ring to 6610, right? Now this is a mix and match topology where you are connecting the 8x10 on the ICX 6610, connecting it to the 10 gigs on the ICX 6450. And each ICX 6450 has 4 10 gig links. All right? So this is a topology.
so
right?
and
You're
this
looking at-
configuration actually it's an open ring, but you know, normally you actually would close the ring, right? It actually didn't look like on the slide, but you would connect, you know, the two stack of 6450 together to have a closed ring, right?
Yep, so this is the whole entire closed ring here. And then with this, the ICX 6610 has all the advanced features for the multicast, layer 3 multicast, right? Then it pushes down the features down to the ICX 6450 stacks over here. Now this is a multicast router, right? This is just a scenario where you have the multicast video streams going from the server through the router, and guess what? It actually connects to a layer 2 switch that does layer 3. Right? You no longer connect it to the layer 3 switch. So this behaves like a layer 3. It does the multicast routing at ICX 6610, but it has that feature and enables the routes to go through, gets the computation, and then it pushes down to all the displays over here. So that's how the data, because I know there's some questions from you, Paul, just now on how this data is being flowed. So hopefully this answers.
So essentially here the value is that you could get now multicasting on very cheap entry-level switches. Like, you know, typically, like here at Brocade, every quarter we have the CEO addressing kind of a whole hand meeting where the CEO address the entire company. Right? That actually happens on multicasting, so that you don't have every employee log to a video server and create like 40,000 streams of video. Right? You just send one stream to all the ports at the edge, but to be able to do that, you need to have multicasting support on each port at the edge, which is typically an advanced feature that requires buying a more expensive switch. So now you could do that with very inexpensive switches at the edge.
Yes, Tom, you have a question.
Yes, so all of the layer 3 forwarding has to happen at the 6610, right? All the packets are
Yes.
punted up there to go.
That's right.
At what point does the performance profile of the 6610 become the bottleneck in the stack as opposed to the backplane connectors that you put together? Because the 6610 isn't a soup engine. It's a packet forwarding switch. I mean, what size of a stack did you look at as a maximum stack size when you started putting this together?
Well, in terms of the number of members in a stack, it's more limited by the hardware itself. Right now, the ICX 6450, the stack capability is 8 in a stack,
Okay.
physical stack, and same thing for the ICX 6610.
Okay, so
So
what
you're looking at 8, if you want, in the whole entire stack. And in this topology, you can have 8 here, 8 here.
So you can have 8 6450 stacked together and then stick a 6610 at the top of that stack to act as a layer 3 forwarding engine, or you have to have a maximum of 8 in the entire stack.
Right. If you are putting everything in a physical stack, then yes, you need, the total number is only 8.
8 is the limit no matter how you mix
Today,
it.
yes.
Yes.
Today.
Today.
Okay,
it
and
is.
so I'm assuming that today means that when there's a bigger batter switch that comes down the line that basically acts like the supervisor engine for the stack, that you'll increase those stack limits.
So it is a software limit also. Today the hardware can go theoretically up to 16.
Okay.
But for us right now, 8 is the number we have stuck with because that's what we saw the sweet spot with our customers. But it can, even with the same hardware, go up to 16. Excuse me, yeah.
I suppose 8's a nice size too, considering failure domain. If you lost the stack for whatever reason,
Yeah,
you don't
yeah,
want to have a
it's-
16 stacked.
It's 384 ports, right?
Putting it in
Yeah,
Yes.
384.
Yeah, it's about-
384 1 gig,
Right.
and then
Plus your-
64 10 gig,
Well,
right?
if you're stacking 16 switches together, you have to ask yourself exactly what you're
Yeah.
doing.
Oh, exactly.
Yeah.
Yeah, there's a point of diminishing returns.
So a layer 2 configuration though, if you have an M lag or something like that, you're just going right out the local. You're not going up to.
Yes.
Yeah, no. If it's layer 2, it would just be local. Yeah.
Kind of like a blade with local switching.
Correct.
Mhm. You know, when I look at this, it's almost like a chassis kind of behavior, but in stackable form factor, right? Having that flexibility.
But you said in a physical stack. You're saying what's the difference? Is there another non-physical stack, or do we? I mean, is it a specific? I mean, the stack. It's just all these switches over the backplane connection. I'm trying to make sense.
Yeah,
of
when
this
I say
diagram
physically
here.
stacked means they are physically stacked together. you know.
Physically adjacent to each other.
Well, they're connected to one another. That's what I mean by physical stack. There's a lot of terminology in the networking world where we talk about virtual stacking and all this. That's why I didn't want to confuse that.
They don't have to be I mean, these are optical links, right? So they could go up to like 300 meters. You know,
So the stacking distance limitation pretty much isn't there. It's whatever.
Well, I think there's some limitation, right? But essentially you could use optics. So
Let me cover that.
Okay.
Let me answer that. So in terms of the distance of the stacking,
Yes.
it depends on the cable that's connected to it.
Okay.
Right? If you're looking at the 10 gig stacking, it can go up to 80 kilometers. If you're looking at the 40 gig stacking, it can go up to 150 meters. So at this point, right? And it's really limited by the cables, not the switch itself.
So actually today, right? So as we certify more optics and more type of link, you know, the QSFP, the 40 gig connection is standard QSFP.
Yeah, so those are transceiver limitations, not
exactly.
Yes.
your hardware
Right,
limitations.
so as we certify, long distance optical QSFP link, that limitation will actually be expanded.
So all of the backplane, all of the stacking interconnection is over standard transceivers?
That's correct.
Yes, that's the standard.
SFP plus and
Actually, that's the
QSFP.
key thing that I didn't bring up.
Yes.
Brocade is big in open standard, as you know. I mean, across the whole entire company, not just our platform.
Yeah.
So in our campus IP, we believe in open standard. The cables are all, whatever that's out in the market. Nothing fancy, nothing new. But anyway, that's my signal of talking too much. We want to be able to show you the demo of the mix and match. So we have Jeffrey to show us some of what we have on the mix and match. So.